Alright, so in one of our previous lessons we talked about something called a z-score, and that's what this lesson 57 is all about. So to easily compare data, we have to do something called standardize. We have to standardize all normal distributions so that they have a mean of 0 and a standard deviation of 1. We talked about this in our other lesson 55. This is called the standard normal distribution, and it has this symbol right here. So this means that it is a normal distribution. This 0 tells us the mean, and this 1 tells us the standard deviation. Z-scores can help when comparing values from different data sets. A z-score is the number of standard deviations a value is from the mean. If x is a normally distributed random variable, and we have this right here, x is equal to n of mu sigma, then the z-score is x, that is our variable, minus mu, which is our mean or our median, divided by sigma, which is our standard deviation. Standard deviation. And this z-score tells me how many standard deviations away from the mean or the median I am. This tells me how close to the mean or the median I am and how I compare to other pieces of data. So how do I interpret a z-score? Well, the standardization produces the distribution of z n01, and the z-score tells me how many standard deviations the value x is above or below the mean mu. If a z-score is positive, that means that the value is larger than the mean. If a z-score is negative, that means that the value is less than the mean. And if I get the z-score of 0, that means that the value is equal to the mean. So let's do some examples here, finding z-scores and interpreting what they mean. So we have a distribution here, x in 6510. What is this telling me? I have a random variable x with a normal distribution where the mean is 65 and the standard deviation is 10. And we have that the value that we care about is 40. So I want to find and interpret the z-score of this standardized normal random variable. So I use this equation up here, that the z-score is equal to x minus mu divided by sigma. In this case, the x that we care about is 40. From the 40, I subtract whatever my mean is, which in this case is 65, and I divide that by the standard deviation, in this case 10. So this is negative 25 divided by 10, or negative 2.5. This is my z-score, negative 2.5. So what is this telling me? Well, it's negative, so that means that this x value, 40, is below the mean. And how far below the mean is it? It is 2.5 standard deviations below the mean. Remember, in a standard normal distribution, 95% of the data is within 2 standard deviations from the data. We learned that in lesson 55. So this data is pretty far away from the mean. If it's 2.5 standard deviations away, that means that it's in the outermost 5% of the data. All right, and then we have one more example. Suppose that I have x in 8.5. This is our mean. 0.75. This is our standard deviation. And the x value that I care about is 10. Find and interpret the z-score of this standardized normal random variable. So my z-score is x minus mu divided by sigma. Our x value that we are caring about is 10 minus the mean, which in this case is 8.5, divided by the standard deviation, which is 0.75. This is 1.5 divided by 0.75, which is 2, positive 2. This tells me that x is above the mean, or to the right of the mean, by 2 standard deviations. And again, 95% of our data is within 2 standard deviations of the mean. So this is telling us that we are, within 95% of the data that's closest to the mean, but still pretty far away. You don't have to worry about that 95%, but it is helpful to know how far away you are from the mean, which is exactly what standard deviations and z-scores tell us. All right, that is all for today. I will see you on Friday. Have a wonderful day.